All right. Good afternoon, everybody. Thank you for joining us. Let me do a quick thing. Are you hearing me? If you are, raise your hand. Okay, we've got some hands raised, so it must be working. Zoom has continued to absolutely destroy their interface, and it no longer shows me that the microphone's picking up my volume. Just one of many horrible changes Zoom has made to their interface. Anyway, you're not here to hear me complain about Zoom. So today we're talking about our new Wi-Fi 7 access points. So as we go through today, you can use chat or you can use the Q&A interface to send in any questions you have as I go through it. This is being recorded and it will show up on our YouTube page and probably tomorrow's afternoon time. Um, so if you have to step away or you want to share it with somebody else, you will be able to find a copy of it there. So we're going to start just very briefly, and today's presentation is going to be pretty short. We're going to start by talking about Wi-Fi 7 in general, just a little quick background on what Wi-Fi 7 is, because it's still a relatively new technology. It's been out, realistically for about 2 years, as far as access points and routers go. But on the client side of things, it's something that, as with all Wi-Fi changes, it drags a bit as far as clients go. So just a short version here. Wi-Fi 7 builds on top of Wi-Fi 6E, basically offering the ability to support 2.4, 5 gigahertz, and now 6 gigahertz in your access points and client devices. And the main benefit of it over Wi-Fi 6E is faster speeds and better handling of crowded environments. So some of the things that enable that to happen, on the 6 gigahertz radio, you can now use 320 megahertz channels. And on 5 gigahertz, you can use 240 megahertz channels, where previously it was limited to 160. They've increased the encoding to 4096-bit QAM, which gives us, I think it's somewhere in the neighborhood of 15 to 20% performance increase on that. We're adding what's called multi-link operation. This is something that is part of the Wi-Fi 7 standard, and we enabled it last summer across all of our Wi-Fi 7 access points. Um, so it allows client devices. What is going on with Zoom now? Okay. So we did get a question come in, so I'll address that here in just a second. So it adds multi-link operation, which allows client devices to be able to simultaneously connect to multiple radios on the same access point at the same time, giving you faster throughput there, giving you lower latency, and a new technology called multi-RU puncturing. So this is something that can be helpful in the past when you were using larger channels, such as 160 megahertz channels. Now we have all the way up to 320 megahertz channels. There's not a lot of RF bandwidth out there to share, and oftentimes you have other devices that are using smaller chunks of spectrum that overlap your large channel that you're trying to use. So with multi-RU puncturing, it allows us to essentially create holes in that big channel that we're using. Um, and so they don't interfere with what's being broadcast. So instead of it using one big channel that gets interference and it causes interference across the entire channel, we can create these holes and create multiple smaller channels, which don't overlap any of the neighboring devices, avoiding that interference issue. So Alex had a question here. So Alex was asking, states extended range. Was that on this previous slide? Yeah, so it's on this slide right here. So the question was, how do we get extended range if we're using 5 gigahertz and 6 gigahertz, which have lower range? And the answer to that is that we're not changing the range here based on 2.4, 5, or 6. So, those still have the same inherent difficulties as you go up in frequency. Overall general range lowers. But with Wi-Fi 7, Because of some of these extra technologies we have, it allows the range to go a little bit further than you would with, say, a Wi-Fi 6 device. So a Wi-Fi 7, 5 gigahertz device, in theory, can have a slightly longer range than a 5 gigahertz 11AC or Wi-Fi 6 device. Um, and they're doing that through a couple different technologies. One is increasing the number of spatial streams that can be supported in Wi-Fi 7. So Wi-Fi 7 can support a lot more spatial streams than the previous ones can. So when you have a lot more spatial streams going, um, while you may not be able to pick up data from all of them, you'll be able to hopefully pick up data from some of them, giving you a little bit extra range. And then also the technologies that have to deal with interference mitigation, something like multi-RU puncturing. But there's other technologies that are part of Wi-Fi 7 that help deal with interference from other neighboring devices, thereby essentially lowering the noise floor and allowing you to get slightly better range. It's not going to be something that would be significantly better range, um, but it is something that, in theory, could give you better range. Now, in the case of adding more spatial streams, we aren't offering anything that has more than 4 spatial streams, which is the same as what we offered in 6E. So, as it comes to our products, you're not going to get the benefit there from that. But in theory, Wi-Fi 7 offers it. So just let's go back to this slide here really quick. So it's just showing some of the differences here. So, in theory, we can get up to 46 gigabits per second, whereas Wi-Fi 6E was 9.6 gigabits per second. So a lot of that is using those additional spatial streams, but we don't have a product that, supports that fast of speeds. There are no client devices that support it, but in theory, in the future, there could be. Multi-link operation can also help when it comes to range because you're sending data across multiple bands on multiple radios. So again, there's a chance that something that may not have been able to get through when you're just using one radio is able to get through when you're using 2 or more. Okay, moving on from that, I just want to touch here on the spectrum and why 6 gigahertz is a big deal. So this is what we've got right now as far as spectrum goes. In the 2.4 gigahertz space, in the US, we have roughly 60 megahertz of spectrum available. In Europe and I think Japan, it's closer to 80. And then 5 gigahertz here, you've got this spectrum here. So you can see if you're trying to use 5 gigahertz and you're trying to use the bigger channels to get the faster speed, so 160 megahertz channels, there's only 2 non-overlapping 160 megahertz channels. And those channels use DFS, which a lot of client devices don't support, and there's some other issues with DFS channels. So even if you can use 160 megahertz, you may run into issues as far as interference because you can only have 2 non-overlapping channels at any one time. So 6 gigahertz gives us a ton more space. So it gives us more spectrum in 6 gigahertz than is available in 2.4 or 5 gigahertz. So instead of 2 non-overlapping 160 megahertz channels, you've now got 7 non-overlapping 160 megahertz channels. So it makes it much more viable to use these bigger channels to get these faster speeds because you don't have to worry about interference issues and you don't have the DFS issues when using 6 gigahertz instead of 5 gigahertz. Now, another thing on here to talk about real quickly when it comes to 6 gigahertz, 6 gigahertz can be used indoors just like you would any other Wi-Fi access point. You cannot use 6 gigahertz products outdoors unless they are specially built for outdoor use. So in order to use 6 gigahertz products outdoors, the power output has to be either extremely low or the access point has to work with a third-party service which tracks licensed 6 gigahertz users and automatically restricts the channels that that device can use based on its physical location or has the ability to restrict the power output on certain channels, again, based on your geographic location. So that requires integration with a third-party service, usually requires a subscription to that third-party service, and then the access point must periodically check in and verify and update what channels and what powers it's able to use. So at the moment, Zyxel does not offer an outdoor 6 gigahertz product, and I don't expect to see one soon because of those issues. But we do have plenty of indoor access points that we'll be talking about later today. So just to explain multi-link operation really quick, this is how you traditionally handle things here with Wi-Fi 6E and before. Basically, your access point broadcasts on 2 or more two or more channels. And then your client device will connect to one of those. It'll choose to connect to your 2.4 or 5 gigahertz channel. So with multi-link operation, what happens is you have two or more radios broadcasting simultaneously on your access point, just like you did with 6 and 6E. But now your client device, in theory, is able to connect to two or more of those radios simultaneously, basically allowing you to aggregate the throughput, lowering latency a little bit, providing a little bit greater reliability, et cetera. Now, of course, the trade-off is one, your client device has to support multi-link operation. And if your device is, connecting to multiple radios, that means it itself is powering multiple radios. So you're going to get a bigger battery or power draw on your battery in that mobile device. So for that reason, a lot of devices don't support multi-link operation. And to confuse things even more, there are multiple implementations of multi-link operation, including that are allowed under the standard, including one that only allows you to make one connection at a time, but they call it MLO. So it can get really confusing when it comes to multi-link operation. Hopefully over time, support will become more common, and B, what modes are supported by the client devices will become more standard. Essentially, we support all versions on our access point. The challenge is on the client side of things. We already talked about that, so I'm going to skip that slide. So all of the access points we'll talk about today, all two of them follow our RF first by design philosophy. So this includes things such as building in extra 4G and 5G filtering for access points that are going to be deployed in office buildings where a DAS system is being used to distribute cellular signals inside the building to help reduce interference caused by those. It also includes things like, moving the antennas off the main board and putting them on their own separate board, extra isolation there for you. And of course, all of our access points support Nebula these days, so you have the flexibility of using traditional management or using Nebula Cloud management for these devices. So with that, we're done talking about generalities. Now let's talk about the products themselves. So these are two new products for us, and these are basically designed to target that space that the NWA110AX and the NWA2AX used to support. We unfortunately phased those out. Those are some of our best-selling access points that we phased out a while back, leaving us with a hole in our lineup, and we are now ready to fill that hole. So the NWA110BE, this is going to be our entry-level Wi-Fi 7 access point. So this one's going to have a street price of roughly $120. It should be, when it becomes available later in March, should be the lowest priced Wi-Fi 7 access point on the market. It is a BE 6500 class device, meaning it can support wireless data rates of up to 6.5 gigabits per second. And this is what we call a BandFlex radio. So for those of you who've been selling Zyxel and remember the still current NWA220 AX.6E, or the anyway, that guy, it's that same idea here where we've got a dual radio setup inside this access point. So there's one radio that's dedicated to 2.4, and there's a second radio that supports either 5 gigahertz or 6 gigahertz. So you have the ability to deploy today using 5 gigahertz, something that basically every client on the market currently supports. And then in the future, when 6 gigahertz support is much more widespread, you have the ability to flip a switch that radio over to 6 gigahertz, and start using that for your deployment. So use it for 2.4 and 5 today, and in the future, you can disable 5 and turn on 6 once Wi-Fi 7 6 gigahertz clients are much more common. On the back side of things here, it's got a single 2.5 gig multi-gigabit port. This can be powered with standard PoE+. So just about any of our PoE switches will be able to power up these access points, no problem. And we've made a change here. I've talked about it on some of my previous slides. This is something that's going to retroactively start applying to some other models. But we've gotten rid of that DC barrel plug wall wart power adapter, and instead of added a USB-C port that supports USB-C PD for powering. So if you don't want to use PoE for whatever reason and need to provide AC power, it will work with any basically USB-C cable and any USB-C charger that supports PD power. I forget the wattage that this needs. Anything that supports at least 30 watts will definitely power it, and you may be able to get away with something a little bit smaller. And then the next new model we have is the NWA210-BE. So this is a BE 1230-300 device, so 12.3 gigabits per second theoretical speed on the wireless side of things. So this is faster than the current NWA130BE, even though this is still a BandFlex device that's using two radios. So again, 2.4 dedicated radio, and then a radio which is either 5 gigahertz or 6 gigahertz. But it does support more spatial streams on that radio than the NWA130BE does. So when using this with Wi-Fi 7 and 6 gigahertz, you will get faster aggregated speeds on this than you would on the NWA130BE. This one has two Ethernet ports, both of which are 2.5 multi-gig ports. One is your uplink port where you provide the PoE plus power to power this up, and the other one is a pass-through port, so you can daisy chain your Ethernet cable onto another device in the area. And again, USB-C PD power if you need to provide AC power. So I put together just a little quick table here to show you, what are the differences between these two models. So they're both BandFlex, so they're both dual radio. The primary difference here is going to be speed, BE 6500 versus BE 12300. And the way we're getting that is with the number of spatial streams supported. So I do want to talk about this because on the data sheet, you will see that the 5 and 6 gigahertz radio support is 4x4. And then on the data sheet, there will be a :2. Whereas on the 210BE, it'll just say 4x4. So what does that mean? So what it means is on that 5 and 6 gigahertz radio, we have 4 antennas that can be used, but only 2 of them are being used at any one time. So it allows the access point to pick and choose which of those 4 antennas to use based on signal strength or interference, things like that. So it gives you a little bit of a boost versus just having only 2 antennas available for those 2 streams. So that's where we're getting our speed difference here, is that the NWA110BE on that 5 and 6 gigahertz radio supports 2 spatial streams, where on the NWA210BE, we support double that, 4 spatial streams at the same time. And then the other significant difference here is that it has that second Ethernet port on it. And then here's what I needed here. So if you are using USB PD power, it needs to support basically 15 watts of power at 2 amps, or 15 volts at 2 amps. Moving on from here, both of these models use our standard, mounting bracket. You guys are probably, if you've been selling our products, are already familiar with these, but they're designed so that you can mount them with screws to a wall, to a ceiling, to a rectangular junction box, to an outlet box, to a round junction box. And then you can use our optional T-bar clips that attach to a T-bar bracket on a drop ceiling, and then this bracket will snap in place onto that. So I just wanted to highlight here the differences. So the NWA110AX was one of our best-selling access points back in the day, and this is taking over that same segment for us at basically, I think, even a slightly lower price than what the NWA110AX used to sell for. So primary differences here are going to be just, we're going here from AX 1800 to BE 6500 on speed, a little bit better output power on those radios for us here, and then a faster Ethernet connection compared to the NWA110AX. So if you used to sell a lot of the NWA110AX, the NWA110BE may be a good option for you. And then on the 210 side of things, so we still have our NWA220AX-6E, which sells for a little bit less than 210BE. And then we used to have that NWA210AX back in the day. So again, the primary differences here between these two models, the 210BE and the 220AX, both are tri-band dual radio access points. So both have that BandFlex option. The difference being with the 210, it's Wi-Fi 7 based, where with the 220, it was 6E based. So that's giving you better speeds, basically double the speed there on the throughput when using Wi-Fi 7 clients. A little bit better output power on the radios versus the 220AX. Both of them have a 2.5 gig uplink port, but the pass-through port on the 210 is 2.5 gigs, whereas the pass-through port on the 220AX was 1 gig. So both of these are available today. So, the primary point for both of these guys here is you've got the flexibility in management, either using these in standalone mode, using our free cloud mode, or using our optional Pro Pack in the cloud to give you some AI enhancements when it comes to supporting the troubleshooting the wireless network. It's got our durable hardware. Both of these devices have our limited lifetime warranty on them. They both use our traditional heavy duty way of building these things. We don't use any electrolytic capacitors, putting heat sinks in the devices, etc., and providing the full feature set and enhancement on security that's available through Nebula. So this today is now going to be our Wi-Fi 7 portfolio that we offer here for you. So the NWA110BE will be available for order through distribution next week, and we should start shipping these within the next 2 weeks. The NWA210BE is available for order today. So when we look through our breakdown here on our models, we've got 3 NWA models. These are our Nebula Flex devices. And then we've got on the higher end here our W series. So these are our products that are Nebula Flex Pro. So they come with 1 year of Pro Pack bundled with them. They also include support for our local wireless LAN controller that's built into our USG Flex security devices. So if you're looking for management, not through the cloud, but you'd still like to have controller-based management, that is possible on the W series there for you. And then we'll be adding a couple more models a little bit later this year. Now, there is going to be a change here. So traditionally, the NWA series access points do not get any partner discount if you are one of our registered partners. We had been offering that on the NWA130BE when we launched the product to help kickstart it. So starting March 1st, the NWA130BE will not be able to get the partner program discount. But we are adding the NWA210BE to get a partner program discount, and we're also adding the NWA220AX-6E to be able to get the partner program discount. So before, this didn't offer the partner program discount. Starting next Monday, it will, as will the NWA210BE. So I did want to highlight for you and let you know that you will be able to get your partner discounts on these 2 models. And with that, we are done with today's presentation. So if there's any questions, do send them in using either question and answer or the chat, and I will answer them for you. So James had a question here. Do we have any recommended tools or apps to help with AP placement to determine best placement with minimal labor? So at the moment, no, we don't have anything officially that we recommend. I would say the leader in the industry is Ekahau. And we do work directly with Ekahau to provide them with specs and details on the performance of our APs so they can integrate them into Ekahau's tool. I think Ekahau is probably the industry leading tool as far as features and stuff like that, but it is expensive. So that is out there for you. We are working on something of our own to come out, hopefully later this year, as a tool to help you with site planning. We do have our current tool. I forget what it's called now, but it's not very good. So the new tool will be coming out hopefully later this year. That makes it easier to import in floor plans, mark what the walls are made of, and give some estimates as to what the heat map would look like once you've deployed the devices themselves. So Greg is asking here, why did Zyxel decide to do a dual radio BandFlex on the new APs? Seems counterintuitive when the NWA130BE was tri-radio. And so the answer to that is to allow us to offer a cheaper Wi-Fi 7 solution. So this is something we learned with the Wi-Fi 6E products. So those were when we first introduced BandFlex, when everyone else in the industry was only providing 6E and tri-radio configurations, and sales were really, really good. There's a lot of people out there that would like to save a little bit of money on the access point and don't really need 6 gigahertz because their client devices don't support it. There's a lot of warehouse tools and things like that that still don't even support 5 gigahertz. So this gives you an affordable way to upgrade to Wi-Fi 7. We aren't canceling the existing tri-band Wi-Fi 7 products. So those are still there, and those are still going to be available for those that want a tri-band access point, but we've expanded the range here to provide affordable Wi-Fi 7 APs for those that don't need 6 gigahertz support today. So that's why we're doing that. I will stick around here in case there's some more questions you guys are working on. While I'm doing that, though, I do want to point you to our forums. Our user forums are at forum.zyxel.com. In addition to a place where you can talk to other Zyxel users and installers, it is something that is monitored by our R&D and product management teams to get ideas as far as features, which features should be focused on for future products. It's also often the first place where you see security alerts, firmware notes, things like that posted up to find them. So it's a good tool to use and to check in on periodically. Okay, I'm not seeing any additional questions coming in. If you do have something, feel free to email me directly. My email's up there on the screen, seanr@zyxel.com, with Sean spelled phonetically there, SHAWN. Or you can reach out to your salesperson and they can get the answer to the question for you. Thank you for joining us. I hope to see you at one of our future presentations.